what we're going to talk about now. In order for a graph to be a function, it must pass something called the vertical line test. That means each input goes to one unique output. So a graph must pass the vertical line test in order to be a function. All of our trig functions pass that. They pass the vertical line. That's why they're called trig functions. They're functions. Well, we have a different rule to see if the inverse is also a function, meaning that it is invertible. In order to see if the inverse of a function is also a function, you have to do something called the horizontal line test. And this would be in order to have now, I'm going to put inverse, but it really just means the inverse is also a function. So first check. You have to first make sure it's a function. Then you have to make sure it passes the horizontal line test. If it does, it's invertible. You can just take the inverse any place you like. So if you look at this line right here, if I did a straight line across it, would it pass a vertical line test, hitting only one point at a time? Yes. If I did something called a horizontal line test, it only can hit one point at a time, it would also pass that. This is known as invertible. That is invertible. So yes, that works. It passes both the vertical line test. So if I wanted to draw a quick line, no matter where I draw a line, it only hit at most 1 point. If I did a horizontal line test, at most it would hit only 1 point. That is invertible. That means it's a function, and its inverse is also a function. For the next one that looks like a sine or cosine graph, would that pass a vertical line test? Yes, it would pass the vertical line test, so it is a function. Would it pass a horizontal line test? No. So its inverse is not a function. That's a problem. That is actually a problem. So we can see it hits multiple times. So nope, that fails. Fail. Big old epic fail. Our next one looks like, if it's going down, would that be tangent or cotangent most likely? Which one falls? Cotangent. It's cotangent. This one would match more like cotangent. Tangent goes up, cotangent goes down. For all of you that graph tangent, hopefully it was going up. This looks like cotangent. Does it pass the vertical line test? Yeah, even though it kind of looks like it won't, it does everywhere. Does it pass the horizontal line test? Yeah. No. Nope. I could prove it. Watch my vertical line. Does it hit more than one place? Yeah, it hits actually an infinite number of times if you keep drawing. So that's a fail. That's a fail for us. That means sine, cosine, tangent, and cotangent do not have inverses that are functions. That's a problem. So what we do to alleviate that is we actually restrict their domains. We also restrict our cell phone usage in this class. And I'm this close to making a thing over there so you have to put your cell phones away. Which, you guys are seniors in high school. I mean, how hard is it just to put your cell phone away for just 55 minutes? All right, so we're going to restrict their domains. We're going to first restrict it, and we're going to talk a little bit more about it. So let's just go through this real quick. So inverse of sine. To do an inverse of sine, we'd first do a regular sine graph. So let's do a regular sine graph. That's what I have the first middle spot for. So I'm just going to do a normal sine graph right here. So sine starts at 0, 0, goes up to 1. It goes down to 0, goes, or sinusoidal axis, goes to -1, and goes back there. That obviously does not pass the horizontal line test. So what some mathematician did is he said, well, let's just draw a little bit more backwards on the sine graph. So I'm going to draw to here. So this is just plain old sine x. And this mathematician said, what if I don't consider it going on forever? What if instead I draw a box around this? And I say, well, this is all I'm going to look at. I'm going to zoom in on this one little place. Everything else is gone. Nothing else exists. This is now invertible. This is now invertible and can actually get to all the angles and stuff that we need to for sine without having any repeat answers. So what they did is they constricted it between negative pi over 2 and pi over 2. So what they did to the unit circle for inverses only, is they got rid of these two quadrants. And they said, I'm only going to focus, so if I have sine inverse, I'm only going to talk about quadrant 1 and 4. So all mathematicians got on the same page. We said, okay, if we're talking about sine inverse, we only can talk about 1 and 4. Which leads us to a slight little problem. One direction's okay, because this would be pi over 6, pi over 4, pi over 3, and this would be pi over 2. But now to get to negative pi over 2, we have to go down. We can't go around the positive direction. Because for me to get to quadrant 4, I can no longer go all the way around here like our yellow circle looks like. Instead, I have to go down. This is going to be very important that we have to go down to these angles, which makes us have a negative pi over 6, a negative pi over 4, a negative pi over 3, and a negative pi over 2. For inverses, there's no such thing as coterminal angles. This is all that exists when I talk about inverses. Quadrants 1 and quadrant 4, and going to quadrant 4 is a negative 4. Let's look what the inverse graph looks like. Now, to graph an inverse graph, all you have to do is take your inputs and outputs and flip them. So the easiest way to do an inverse graph is to actually plot 3 points and flip your x and y values. So we already have 3 points. So if we look at the bottom left of that orange thing, that is negative pi over 2, comma, negative 1. Flip those two. For the inverse, I'd be plotting negative 1, negative pi over 2. So we would go negative 1, negative pi over 2. I just flip them. That is negative 1, negative pi over 2. The next one's really easy to flip because that's the point 0, 0. I bet you if you flip 0, 0, it becomes 0, 0. So we have a point at 0, 0. And our final point is pi over 2, 1. Flip that, you have 1 pi over 2. And our graph is going to look like that.
So it's the same, kind of, except that
Kind of. It's kind of flipped, right?
So is that I have to change the x for the y-axis?
Yeah, it's basically because of those x and y axes. Don't worry too much about this graph. I'm not going to ask you graph this, okay? So you don't have to do transformations with it. You don't really have to know it. The big thing you need to know from what I'm showing you right now is sine is restricted to quadrants 1 and 4, and to use quadrant 4, you have to use negative angles. And maybe this doesn't make any sense at all, but it'll make sense when we're actually doing some problems. So the inverse of sine, noted 2 different ways. See how this is called arc sine? That's a remnant of you couldn't really write superscript. So if you couldn't write superscript, they came up with a different way. They called it arc sine. Arc sine and sine inverse mean the exact same thing. Arc sine and sine inverse, I'm asking the exact same question. They exist only in quadrants 1 and 4. And we'll put more concrete reason why it has to be 1 and 4 in just a second. All right, I actually want to put something on my next slide real quick. I would like to see if I have a unit circle. I do. Cool. This is important. Okay. This spiel right here. This spiel right here tells you why we use inverses or how we use inverses. So up until now, I would hope if I asked you for the sine of pi over 4, you'd know that's square root of 2 over 2. Think about the process you'd use. You'd say, okay, sine of pi over 4 would lead me to square root of 2 over 2. I'd look at pi over 4, sine comes as the y value, I have square root of 2 over 2. Does anyone have questions on how I just did that? Okay, so we're all clear that sine of pi over 4 equals square root of 2 over 2, I hope. Inverses work backwards. So if you look down here, I'm asking what's the sine inverse of square root of 2 over 2? Your job is to find square root of 2 over 2 on the unit circle. Now here's the problem.
You're looking for the sum.
Do you see my square root of 2 over 2 here?
Yeah.
Do you see the square root of 2 over 2 in quadrant 2? I can't have two places to look for. So that's why it's only in quadrants 1 and 4, because if I put this on a test and I wanted pi over 4 and Jason put 3 pi over 4, technically he's correct unless we restrict the quadrants to 1 and 4. So that's why mathematicians said, oh, you can't have two places to find the exact same value. So erase that, and then they said, get rid of those two quadrants. Now, everyone knows to look here. So when I ask for sine inverse, you should cover up half your unit circle. Don't even look over there. Your job is to find square root of 2 over 2 on quadrants 1 or 2 and work backwards. What angle does that happen at? 45. Pi over 4, or 45 degrees. So the way I look at this is regular trig takes an angle and spits out a value. Inverses take a value and spit out the angle it occurs at. So we're just reading the unit circle backwards. We're now finding the value and figuring out what angle matches that value. Those are inverses. So let's see if we can practice those. So my first one says find the inverse, sine inverse of 1/2. Our job is to look at our unit circle. As a reminder, maybe I should leave this completely off because we're in sine inverse land. We have to erase basically that whole half of this. Because can anyone find where sine equals 1/2? At pi over, and that's how you give me directions to get there, right? So you would say, oh, you know what? 1/2 is here. The direction is pi over 6. So we're going to go pi. Oof. That seems a bit aggressive. So we'd go pi over 6. So see, our answer is an angle now. It's the direction to get there. The next one is the hardest one and the one that people are going to repeatedly get wrong on tests and stuff. Arc sine equals negative square root of 2 over 2. Can we figure out where sine equals negative square root of 2 over 2? Can you see that on your unit circle?
Yes.
So it's right here, right?
Yes.
So what's going to happen on the test is you go, I found it, Mr. Pabian. I know how to do this. I work backwards, and I write 7 pi over 4. That is incorrect. 7 pi over 4 means that I went all the way around to get there. It's got to be negative pi over 4. So that's why I always draw like black here. I'm just like, I can't go that direction. I'm stuck here. I have to go backwards. So that's why on your sheet, or when I put my little thing here, maybe I should bring it up here, I made sure to point to myself that if I'm using inverses, I have to use negative angles to get to quadrant 4. I can't go positive because there's this wall blocking me. If you look here, to get to 3 pi over 4, I have to go outside that orange thing. So instead, I just go backwards. We go negative angles. So on the test, 7 pi over 4 would be incorrect. You'd have to put negative pi over 4. Would 7 pi over 4 be worth something? Yeah, but you're not going to get full points. It's got to be that negative pi over 4. Yes? Oh, I think I asked for both. We'll do both right now. That's a good question, because I will give you directions. So this one doesn't give us directions. So we'd go pi over 6 or 30 degrees. Negative pi over 4 or negative 45 degrees. Who can find the sine inverse of square root of 3 over 2? What angle does that occur at? Was it pi over 3? Which is not 30 degrees. Pi over 3 is 60 degrees. So if we know the first quadrant, we can just reflect it. We have, like I said, all you really need to know is the first quadrant. Because you should know sine goes 1, 2, 3. So if I ask for the sine of 1/2, that's my first angle. It's pi over 6. Arc sine of negative square root of 2 over 2. What would the arc sine of square root of 2 over 2 be? pi over 4, so negative would be negative pi over 4. Sine is kind of easy that way, that if you know the positive version, you know the negative version. That is sine inverse. Questions on that? Oh, I should put something here. I'm sorry. Arc sine, a lot of times I don't leave it as arc sine. I always change it to sine inverse. It's just easier for me to write. So if I'm doing a whole bunch of stuff with it, I just change it to sine inverse. They mean the exact same thing. All right.
Wait, I have a question.
Yeah, go. Who said that? Yeah, Elijah.
It's negative c squared over, or whatever.
Yep.
2. So that's pi over 4.
That's negative pi over 4.
Negative pi over 4, but it's actually for arc sine, so.
Arc sine is the same thing as sine inverse.
Right, so why is it still negative? Why is the answer negative?
Why is the because you have to get there? So like I said, it's right here. Negative square root of 2 over 2 is right here, so it points to 7 pi over 4, but we can't get there. I said you can't go through these that doesn't exist, so you have to go down.
Right.
The only way to go down is to make this a negative pi over 6, a negative pi over 4, a negative pi over 3, a negative pi over 2.
Okay.
So for sine inverse, you have to use negatives to get down to quadrant 4. There is a wall right here that won't let you go all the way around. All right, let's talk about cosine. Cosine's a little nicer. We don't have to worry about negatives. Because if you remember what cosine looks like, cosine starts at 0, 1, sinusoidal axis, down to negative 1, and back up. That is plain old cosine. If you're playing along at home, you might think that we extend this here and put a box around it. If I extended this here, that would go down. Maybe I'll draw it real quick. Don't put this on there because it's incorrect. If I extended it backwards like I did to sine, and I drew a box around this, would this pass a horizontal line test? No, so we can't pick the same quadrants. We can't say it's quadrants 1 and 4. Instead, we don't do anything to the cosine. We're just like, well, why don't we just already take from here to here? That passes first the horizontal and vertical asymptotes. Well, that's from 0 all the way to pi. And 0 to pi are our first 2 quadrants. It is quadrants 1 and quadrants 2. So cosine inverse is going to exist in quadrant 1 and quadrant 2. And that means this stuff is all gone. It's good and bad. It's good because I don't have to worry about negative angles. It's bad because I can't just reflect my answer. I do have to go all the way to quadrant 2. So we don't have to put those negatives on there. It just works as is. We just go from here to here, and that's where I look on my unit circle. Now, a graph of this really quick is just find your x and y values and flip all of those values. So this would be, I need to take that down a notch. So we'd have 0, 1. Flip that, and I would have 1, 0. Our next one is pi over 2, 0. Flip that, you have 0 pi over 2. Guess I should be writing those down, just trying to get through so we have time. And our last one is pi negative 1, so I plot the point negative 1 pi. And our graph would look something like that. This would be my arc cosine or cosine inverse x. Once again, don't worry too much about this graph. Instead, worry about what quadrant they exist in. It exists in quadrants 1 and 2. So if I ask you to find the cosine of 1/2, your job is to locate where in the unit circle does it equal 1/2. Now it equals 1/2 in 2 locations. That's why we have to make sure we cover up the bottom half of our circle. So now there's only one place that cosine, bless you, one place that cosine equals 1/2, and does anyone know where that is? Where does cosine equal 1/2 in radians? 5 pi over 6?
Or no, it's
6.
it's pi over 3.
Pi over 3. Yeah, let me put this back into cosine world real quick. So if I was doing this, I'd put my hand over the bottom quadrants. I'd find where cosine equals 1/2. That equals 1/2 right here, which is pi over 3 or 60 degrees. 1/2 is right here, pi over 3. Negative 1/2 is here, but that's not what I'm looking for, so it's going to be pi over 3. Or 60 degrees. What was that?
It's inverse cosine, then
We're trying to figure out where that value exists, and we're pointing to what angle that is. Maybe try to the next one. So the next one says find where arc cosine equals negative square root of 2 over 2. That's the same thing as cosine inverse. All it's asking you to do is find out where cosine equals negative square root of 2. So I go back to my unit circle, and we're looking for negative square root of 2. What angle points to where cosine equals... What was that?
3, 5.
So many answers. We definitely shouldn't be at 7 pi anywhere.
3 pi over 4.
It'd be 3 pi over 4. Remember, we have to cover up these bottom two quadrants because it only exists in quadrants 1 and 2. Because if I brought those back in, we'd have multiple answers, but I just want one. We figure out where cosine equals negative 2 over square root of 2 over 2, and we just give me directions to get there, and that's 3 pi over 4. That's all you're doing. It is not overthinking this.
what was the whole thing about like?
That's for sine inverse.
These ones are easier.
Yes. Well, yeah, no.
Yeah, that's like sine versus.
All right, so arc cosine is the same thing as cosine inverse. It is going to be pi. Pi is correct. Because if we go back to our unit circle, we locate, I guess I erased it a bit. So does cosine equal 1 at pi?
No.
Uh-oh.
It's negative 1.
We're looking for cosine equals 1, so it can't be pi. It would have to be 0. It can't be 2 pi, because 2 pi means you went all the way... Oh, I can't go all the way around, because nothing exists here. You just fall off the face of the earth. So it has to be 0 degrees. So this one has to be 0. No 2 pi. No coterminal angles in inverse land. Inverse land exists in those two quadrants and those two quadrants only. Sine is quadrants 1 and 4. Cosine is quadrants 1 and 2. I'm going to show you an easy way to remember what quadrant they live in. You're going to write, this is what I would do if I had to give if I'm on a test or something like that and I want to put something on there to help remind me. You're just going to write cosine. So I'm just going to write cosine, and I know what quadrants these things exist in. So neither of them exist in quadrant 3. Now I know if I'm reading cosine inverse, I find quadrants 1 or 2. If I have sine inverse, I do 1 and 4, reminding myself if I get to quadrant 4, I have to go in the negative direction. Yeah.
Will there ever be something in 3?
No. We're gonna go through cosecant, we're gonna go through secant, we'll go through cotangent, we'll go through tangent. No. In fact, we're gonna learn that cosine and secant inverses exist in the same place. Sine and cosecant exist in the same two places. So once we have this down, I actually have cosecant and secant taken care of too. What was that?
What about tangent?
Tangent actually exists in 1 and 4 if you want to know. Cotangent lives in 1 and 2, which is a big problem. But we'll worry about that later. All right, just a little recap. So we can write that cosine. I do want to put something down here. If I ask you to find sine, you will do sine of an angle. I will give you sine of an angle. You'll find that angle, and you'll find a value. So anytime you're using regular sine, cosine, tangent, any of those, the result is a value that's on your unit circle. When I give you inverses, though, you take an inverse of a value, which are those values on the outside. And the directions to get there is going to be an angle. So if I ask for an inverse of something, your answer automatically has to be an angle. So you're looking for an angle that represents this. If I ask for sine, I'm asking, look at the angle, find a value. Inverse is, look at that value, find an angle.
Oh, that's what you want for all of them and not for... You want us to always find the angle?
That's what we're always doing for inverses.
Okay, so you don't want it
That is an angle. Pi over 6 is an angle. 30 degrees is also an angle.
Okay, yeah.
So whether it's in degrees or radians,
Okay.
so maybe I should put that, these are always going to be in radians or degrees. So sine, you'll take a radian or a degree and give a value. Inverse, you'll take a value and give me a radian or a degree. It's nice to know what you're looking for an answer. Real quick, just so we can go in between the two. Bless you. What's the cosine of 3 pi over 4? Negative root 2 over 2.
Yeah.
Perfect. What's the cosine inverse of negative square root of 2 over 2? It turns out that is 3 pi over 4. Will that work every time? No. For cosine, it will. What's the sine of 7 pi over 6? Is negative 1/2. So, based upon this, that means the arc sine of negative 1/2 should be 7 pi over 6. Is it? No, what is it actually?
Negative pi over 6.
It's actually negative pi over 6 because you have to stick to the quadrants and you have to go down. So our initial thought might be it's 11 pi over 6. It is not. It has to be the negative pi over 6. Real quick, using our calculator. So if I look here on these two problems, this is really just to help you in the homework. I used to not put this, but it helps you. I want you to find sine alpha equals 0.88, but I first need to solve for alpha. Real quick, let's pretend I had something else here. Just picture this on here real quick. Let's say I had square root of alpha equals 5. How would I get alpha alone? If I had square root, I would square both sides. We'd have 5 squared, right? So alpha would just equal 25. Now think about what square and square roots are. They're inverses of each other. They undo what the other one does. Well, we just learned inverses. Inverses undo what a function does. So if I need to get rid of sine from one side, I never, ever, 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 I'll see it, but I never want to see this. You cannot divide by sine. That doesn't make any sense because you're not multiplying by sine. It's sine of. It's already a function. It's kind of like if I divided by square root on both sides, get rid of square root. It's the same thing. Instead, what you're going to do is you're actually going to take the sine inverse of both sides. It is just like squaring both sides. This is just like squaring both sides. I'm just taking the sine inverse of both sides. And just like when you take a square root and you square it and you cross the two things out, sine inverse of sine cancel each other out. And you're now left with alpha equals sine inverse of 0.88.
And you put that in the calculator.
You put that in the calculator, but be careful, it does say use degree mode. So that's what makes this a little more difficult because you don't know. I'm giving you a value. You have to kick out an angle. You have to know if it's going to be radians or degrees. So we're just going to type in sine inverse, which is basically a second sine button of 0.88. Let's round that to the nearest tenth because we are in degrees. What does that come out to the nearest tenth?
61.6.
61.6 degrees is correct. We can do the same thing for cosine. We can do the cosine inverse of both sides. So we can do I wanted orange. We can do cosine inverse of cosine alpha equals cosine inverse of a 0.88 Cosine inverses cancel out. We should just have alpha equals cosine inverse of 0.88, which you should have gotten out, correct me if I'm wrong, 28.4 degrees? I wonder what 28.4 plus 61.4 equals. Huh. Whew. What if that means anything? Probably not. Probably not. All right, guys.